Alright, this video is for Geometry NTI Days 42, 43, and 44. And we're still in this review paper. The last video I said was the last video, but I got tired of talking. So this video should definitely be the last video for your NTI, unless I can't make it all the way through, which my voice is sounding kind of crazy right now, so I might not be able to make it. So this one is for part 2 on the review paper. We're going to go 11 through 20. So number 11 says, in the figure below, angle PRQ measures 70 degrees. So I'm going to go ahead and mark that. PRQ is right there. 70 degrees. So remember, you do look at the letter in the middle, R, and you can use the P and the Q to kind of trace out that angle. It says angle PQR, so PQR measures 75 degrees. So that's there, 75 degrees. And points R, P, and N are collinear. R, P, and N, they're on the same line, collinear. What is the measure of angle QPN? QPN. So this is the one that I'm looking for. So this is pretty much the same thing as what you saw on question 7, except it has all these words and you have to fill in the measurement. So you have the 2 remote interior angles, and they're going to add up to this one here. This is our exterior. So 70 plus 75 is all you have to do, and that's going to give us 145 degrees. And that will be our final answer. Number 12, in the figure below, A, D, B, and G are collinear. A, D, B, G, we can see they're on the same line. If angle CAD measures 60, CAD, so this one right here is 60. Angle BCD measures 40, so BCD. This one here, just there on that side, not the whole thing. And angle CBG, CBG is this exterior angle here. And that one is 150 degrees. What is the measure of angle ACD? ACD. So this one right here, this little piece right in there that I colored in, that's the one that we're looking for. So if you're given an angle on the outside, you do want to use that to help you get onto the inside. We can do that one of 2 ways. I'm just going to go ahead and find all of the angles in this triangle here on the right side. So I know the 150, and then this one right here next to it, angle CBD, those make 180. So I can do 180 minus 150. 180 minus 150 is going to give me 30 degrees here on the inside. I don't really need that one, but I just wanted to go ahead and find it. So to get this third one here, I definitely do need that one. I can do 2 different things here. I can either add these and then subtract that from 180, or I can do 150 minus 40, because 150 is my exterior, 40 is a remote interior, and this one is a remote interior also. So whichever way you want to do it, I'm just going to do that because it'll give it to me in one step. 150 minus 40, my remote, or my exterior minus my remote interior, and that's 110 degrees. So I'm going to put that there. And then I do need to find this angle that's right next to it. That's supplementary, this angle ADC. So since it's supplementary, these 2 are going to add up to 180. And I know that because they make a line. So I can do 180 minus 110. And that's going to give me 70 degrees. So in this little triangle, I have a 60 and a 70, and I'm looking for that one. So I can do 60 plus 70. Which is 130. And then 180 minus 130, which is 50 degrees. So 50 would be that final answer there. Really, this 110 is an exterior, and 60 and the one we're trying to find are remote interior. So I also could have done 110 minus 60. That will give me 50 also. So a couple different ways that you can work that problem out. Just the big things you need to know is that all the angles in a triangle add up to 180, and that your two remote interior angles add up to your exterior. And I guess also too that your exterior and the one next to it make 180 because they make a line. So you need to know that too. All right, number 13. Find the length of FG. So I think I'm going to need a calculator on this one, so I'm going to pull that up. Okay, so I'm looking for FG. FG is the segment here. If triangle FGH is similar to triangle LMN. So I'm going to start with FG. I have to make a proportion, and I'm going to look up here. FG is in the same place as LM. So over here, I'm looking for LM. It's right here. It is 20. So X over 20. And then my 117 on top, because I put X on the top, and that's GH, is in the same place as MN, which is 45. So from there, I can just go ahead and cross multiply. X times 45 is just 45x. And then I need to cross the other way. 117 times 20, which is 2,340. So 2,340, and then divide by 45. And I get 52. So X equals 52, or F of G is equal to 52. All right, so if they're similar, make a proportion, cross multiply. Number 14, in the figure below where triangle QRS is similar, and that's what that symbol means, is similar to triangle JKL, lengths given are in inches. What is the perimeter in inches of triangle JKL? So we want the perimeter of this triangle, which means that we have to add up all the sides. But the only side we know right now is 10. So we need to find these other sides. So I'm going to put an X and a Y. So I'm going to start with JKX. So X over. I'm going to come back up here and look. JK is in the same place as QR. And I'm looking here. QR is 27 equals LK, which is 10. And I'm just using that one because that's the one that I know. I go back up here. Where am I? LK is in the same place as RS, which is 30. And then I can cross multiply this. So X times 30, 30X. 27 times 10, 270. Divide by 30. And I'm going to get X equals 9. So I'm going to come back over here and I'm going to put the 9 on there. And then I need to find side JL or Y. So I have Y over, let's see, JL with QS. QS is 18 equals, and I'm just going to keep this part the same because I know 10 and 30 correspond together. So 10 over 30. Cross multiply. I didn't really leave a good space here, did I? Okay, let's see. 30y equals 18 times 10 is 180. Divide by 30. And I'm going to get y equals 6. So I'm going to add that on there. Okay, so all I did was make my proportions just like I did on number 13 and cross multiply. I just had to do it 2 times because I needed 2 sides. It's asking for the perimeter, so I'm going to add these up. 10 plus 9 plus 6. and I believe that is 25. So let's see. I'm just going to put in the middle. P equals 25. And that is my final answer. That's the perimeter of that triangle. Also on this problem, you could do it in one step. You could find the perimeter of this triangle, and your missing value would be this. So you could set it up like use your 10 over 30. 10 over 30 equals x, the perimeter of this triangle, over the perimeter of that triangle. I guess that would be a little bit faster if you wanted to do it that way. Okay, moving on, number 15, find the missing side x. You have a right triangle. You have two sides given to you. We're going to be using the Pythagorean theorem. A squared plus b squared equals c squared. We need to make sure we identify the hypotenuse first, the longest side across from the 90. In this one, it is 11, and that's the only one we really need to mark up as a certain letter. So that one is C. 9 and x, as long as one of them's A and B, we're good to go. So I'm going to do 9 squared plus x squared equals 11 squared. 9 squared, and I'm going to come over here so I have some more room. 9 squared is equal to 81 plus x squared is equal to 11 squared, which is 121. And I'm going to subtract 81 from both sides. Oh, running out of room, so I'm going to move it over here. So I get x squared is equal to 40. And then I need to take the square root. And since 40 is not a perfect square, I do want to try to factor tree that number down. So I hope my hand wasn't in the way the whole time. Sorry if it was. So 2 and 20, and 2 and 10, and 10 will break down into 2 and 5. I'm looking for a pair of the same number. I do have a pair of 2s, and then I have a 2 and a 5 left over. So my pair 2 is my outside number. And since I have more than one number left over, I have to multiply them together. 2 times 5 gives me 10. So 2 radical 10 would be my answer. You can also check that decimal in your calculator. Square root of 40 is going to be 6 point something, like 6.3 or 4 or something like that. It is 6.32. And then it will be multiple choice on the NTI day, so you could check and see which ones will give you that same decimal. All right, 16, find cosine A in the triangle below. So make sure you know your SOHCAHTOA. Sine equals opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. This one wants us to find cosine, and it tells us to use angle A. So we're going to be looking here, adjacent over hypotenuse. So adjacent to A is 24 over the hypotenuse on the bottom, which is 30. And then you do always want to reduce your answers down. So the biggest number that goes in 24 and 30 would be 6. 24 divided by 6 is 4, and 30 divided by 6 is 5. So cosine of angle A would be 4 over 5. Number 17. For the right triangle ABC below, what is the sine of angle A? So I'm going to go back over here. We're talking about sine, so we need opposite and hypotenuse, and we're looking at angle A. So angle A. We need opposite, which we don't know. And then the hypotenuse, the biggest one across from the 90, 45. So we do know that. So we do need to find this side here. So we need to use the Pythagorean theorem. So that is my hypotenuse. I just need to make sure I put it in the C position. So I have 36 squared plus x squared equals 45 squared. I use my calculator here. 36 squared is 1,296 plus x squared equals, and then I use my calculator again, 45 squared, 2,025. And then I need to subtract my 1,296 to the other side. Make sure I do it on both sides. So 2025 minus 1,296. Probably should have done that in my head, but that's okay. It's 729. So x squared is equal to 729. And then my last step is to take my square root. I'm going to do that on the calculator here. Square root 729. And I get 27. So this side x is 27. So when I'm looking for sine A, I have 27, the opposite over the hypotenuse, 45. And then I want to reduce that down as well. The biggest number that goes into 27 and 45 is going to be 9. 27 divided by 9 is 3. And 27 divided by 9, or what am I talking about? 45 divided by 9 is 5. So my complete answer, my final answer is 3/5. Also, if you picked up on that the 36 and the 45 were making a Pythagorean triple, because those two numbers are also divisible by 9. 36 divided by 9 is 4. And then again, 45 divided by 9 is 5. You can see they're going to make the 3, 4, 5. So you could have done 3 times 9 to give you the 27. But if you didn't see that triple, that's okay too. The Pythagorean theorem works every single time. So we did have to use it to find this missing side. And once we go through the Pythagorean theorem and find that missing side, it's going to give us the sign, the opposite, the 27 over the hypotenuse, 45, which we did down here. And then we just need to reduce it to get the 3/5. All right, number 18. Write a trigonometric equation to represent the value x in the figure. So we're given this 30-degree angle. We want to mark up what we have in relation to that angle. X is going to be the adjacent side, so I want to put an A on that. And then 15 is across from the 90. It's my longest side. It's my hypotenuse. So A and H. I'm looking at these. A and H right here. It's cosine. I do cosine, then I have to put my angle, which is 30, which equals adjacent on top, hypotenuse on the bottom. So adjacent x, hypotenuse 15. We just want to take this one step further to make the trigonometric equations that equal to x. So if my number's on the bottom, I have to multiply to get it to cancel out. So my final answer would be 15 cosine 30 equals x, which I think I left it like that for you guys, but now I can't really remember. Yeah, okay, so it just doesn't even have the equal x. All right, so it's really a trigonometric expression, but that's okay. All right, number 19. Write a trigonometric equation to represent the value of x in the figure below. So we're just doing the exact same thing. We're given the 66 degree, and then we mark up what we have. X is adjacent, and the 16 is across from it, so that is going to be opposite. So O and A, I can come back over here. I'm looking at these O and A. That's going to be tangent. So I have tan. Then I put my angle, 66. Is equal to, tangent is opposite on top, adjacent on the bottom. So my opposite was 16, and my adjacent was x. So this one is a little bit different from the one that we just did. because this one that we just did has the number on the bottom, and this time we have x on the bottom. So when that happens, x and your trig with your angle are going to switch. So we get x equals, so that switch, 16 is still on top. And then instead of x, we have tan 66 on the bottom. So that would be your final answer there. And then our very last one, number 20. Write a trigonometric equation to represent the value of x in the figure below. Oh, well, it should be about the angle, question mark. So theta will represent the question mark. All right, so in relation to the question mark, the 4 is across from it, so it is the opposite. And 9 is across from the 90. It's the biggest side, that's your hypotenuse. So I'm going up here. O and H is sine. So sine. And then we put our angle. Since we don't know our angle, it's a question mark. It says use theta. So sine theta equals, sine is opposite over hypotenuse. So opposite was 4 and hypotenuse was 9. And you'll leave it just like that. Good luck on your last NTI assignments.